Hello. For our CS184 final project, we implemented a 3D snow simulator using the material point method as well as with OpenGL rendering.
Snow in graphics is typically implemented using npm. In Project 4 we used a particle and spring based method for simulating cloth. npm is a hybrid particle and grid based method which leverages the advantages of both and allows us to freely control many types of snow properties using only scalar parameters.
Okay, so we implemented the material point method as described in the original paper with a few minor differences. First of all, our implementation is less efficient, so we use the lower grid resolution as well as less particles. And secondly, rather than doing the semi-implicit numerical integration for the physics, we used an explicit numerical integration from class for simplicity. And now we'll demonstrate some results from our snow sim.
So as you see some snow particles dropping on this side. So this one's simulated with a medium coefficient of static friction, and you can see compare and contrast to this side, in which the static friction is somewhat lower, and some of the parameters of the snow have changed, so the clumping properties are slightly different, as you expect of regular snow.
Okay, here we imitate the snow plow demo. So as you can see, our plow pushes snow to the side.
So this demo is a snowball hitting the wall, which we call this wall crash. So as you can see, you see some behavior that's kind of like similar to the paper, in which part of the snow sticks to the wall, but part of it actually cleaves off and falls. So fracture is a property that the npm method handles particularly well.
Okay, and finally, we imitate the cannonball demonstration. So as you can see, the cannonball shoots through the tower and destroys it.
So we learned quite a few lessons from implementing this project. One being that understanding the physics equations presented in the paper that we read was quite difficult, but actually implementing it was not so bad. Just like write a lot of mathematical code. On the other hand, setting up CMake, OpenGL, and threading and other sort of C++ and system-specific things was very scary. Took up a lot of our time. And also optimization of our code, as you mentioned, our code wasn't the most efficient, so we spent a lot of time optimizing it. This was also very time consuming.
Okay, so finally, in conclusion, this was quite a difficult but also rewarding project, and we would encourage this, especially if you enjoy physics simulation. This project is very suitable, but of course there are lots of parts that are not related to physics as well. Okay, thank you.